In an era dominated by AI breakthroughs and volatile global markets, we constantly seek certainty. We build complex models to predict everything from stock movements to social media trends. But what if the very foundations of our data analysis are quietly undermining our understanding, leading us astray in a world that refuses to follow predictable patterns? What if our most trusted statistical tools, the ones powering modern predictions and policy, are built on assumptions that current events have simply shattered? This isn't just an academic debate, it's a critical question for anyone making high-stakes decisions in a rapidly changing world. Traditional statistics, often called parametric tests, rely on elegant mathematical assumptions. They assume your data fits a specific shape, like a normal bell curve. They assume equal variances or large sample sizes. For decades, these assumptions served us well. But the sheer volume and complexity of data we generate today, from geopolitical sentiment on X, formerly Twitter, to user engagement with a new AI assistant, rarely conforms to these neat boxes. It's often skewed, ordinal, or simply too chaotic to fit the old rules. Ignoring these statistical truths isn't harmless. It's a silent saboteur. Imagine an AI model trained on assumptions about user behavior that don't hold true, leading to biased recommendations or even privacy breaches. Consider economic forecasts based on market data that is anything but normally distributed, amplifying uncertainty. Or even sports analytics making critical player acquisition decisions on faulty statistical premises. The hidden patterns we seek, the surprising consequences unfolding around us, are often obscured by our adherence to outdated analytical frameworks. This is where an entirely different class of tools emerges from the shadows, non-parametric tests. These are the unsung heroes of modern data analysis, offering powerful alternatives when your data simply doesn't play by the traditional rules. They free us from rigid assumptions, allowing us to analyze data that is ordinal, ranked, or just plain messy, yet still extract meaningful insights. Think of them as the flexible, adaptive intelligence of statistics, perfectly suited for the unpredictable nature of our interconnected world. One such critical tool is the Mann-Whitney U Test. When you need to compare two independent groups, say, user satisfaction ratings for a new AI chatbot versus an older version, but your satisfaction scores are ordinal ranks, not normally distributed, the Mann-Whitney U Test steps in. It evaluates whether the populations from which those two samples were drawn are statistically different without assuming a normal distribution or equal variances. Instead, it compares the ranks of all observations. Consider its immediate relevance in the tech industry's battle for market share. A startup launches a new social media feature, claiming higher engagement than a competitor. Instead of forcing their often skewed likes or shares data into a parametric test, the Mann-Whitney U allows them to robustly compare the median engagement levels. It's a stark example of how this test provides clarity where traditional methods would falter, making for more reliable A/B testing and strategic decision-making in a hyper-competitive landscape. Another indispensable method is the Wilcoxon sign rank test. This is your go-to when you have paired data, measurements taken from the subjects under two different conditions. For instance, measuring a group's sentiment towards a new global trade policy before and after a major economic report, where individual responses are highly subjective and unlikely to be normally distributed. It assesses if there's a consistent difference in ranks within those pairs, ignoring the strict requirements of its parametric cousin, the paired t-test. Its impact resonates across fields. Imagine a clinical trial testing a new wearable health tech device. Instead of assuming normal distribution of biometric changes, the Wilcoxon sign rank test can analyze changes within the same individuals after using the device, providing robust evidence for its efficacy or lack thereof. Or consider evaluating an AI's impact on employee productivity, measuring before and after scores, even if those scores aren't perfectly normal, yields valid conclusions, impacting the future of work itself. Why are these tests more crucial now than ever? We are swimming in a data deluge, information streaming from every device, every interaction, every corner of the globe. Much of this data is qualitative, observational, or collected under conditions that defy traditional statistical ideals. From predicting election outcomes based on social media sentiment to analyzing the performance of complex algorithmic trading strategies, assuming normality is often a dangerous simplification. The true complexity of our world demands analytical tools that embrace, rather than ignore, this irregularity. And the non-parametric toolkit extends even further. Need to compare more than two independent groups without normal distribution? The Kruskal-Wallis test is your answer. Looking for correlations between ranked variables, like a country's economic stability and its social media censorship score? Spearman's rank correlation coefficient provides robust insights. These aren't obscure academic curiosities. They are practical, powerful methods enabling deeper, more honest interrogations of data, especially when dealing with human judgment, social phenomena, and emergent technologies. This isn't merely about choosing a different formula. It's a fundamental shift in statistical philosophy. It's about recognizing the limitations of idealized models and embracing the messy reality of data in an age of unprecedented change. As AI algorithms become more pervasive, as geopolitical events unfold with dizzying speed, and as economic forces remain unpredictable, understanding to use non-parametric tests ensures we're not building our future on shaky statistical ground. It empowers us to make smarter, more reliable decisions. So, as you navigate the turbulent waters of AI advancements, economic shifts, and global events, remember, statistics without assumptions are not a fallback, but a frontline defense. Non-parametric tests are indispensable for extracting truth from complexity, for uncovering those hidden patterns and surprising consequences that shape our world. They are the keys to a more robust, more honest, and ultimately, more accurate understanding of the forces at play.